This is a really good follow-up problem to my previous video. We've got a graph ax squared plus bx plus c passing through 3, 0. That's one of its roots. And it's also got a minimum point at 1, minus 20. What we want to do is find the original a, b, and c that would produce these points. So once again, let's actually plot some points on our graph first to see how it looks. So we've got 3, 0. I'm going to plot this here. 3, 0. And our minimum point is at 1, minus 20. So that's going to be quite far down, 1, minus 20. We now need to use the exact same properties of parabolas like we did in the last question. Namely, that the minimum point must be symmetrically spaced between those roots. So if we've got 3, 0, we have to travel 2 along the x-axis to get to our minimum point at 1. That means we need to travel another 2 along the x-axis to get to our second root. So if we travelled 2 to get to 1, another 2 will take us to minus 1, 0. If you just check, does that work? Yes, between 1 and minus 1, and 3, 1 is in the middle of those two. What I'm going to do now then is the exact same kind of thinking as we did before, and that's thinking about, well, these two roots produce this quadratic. It would be x plus 1, x minus 3. Right, these factorise to give those roots, don't they? Okay, well, same kind of thinking as before then. Let's consider the minimum point of this quadratic graph. So we would have, if we expand it, x squared minus 2x minus 3. And completing the square on it, we would have x minus 1 squared minus 1 minus 3. So that gives us x minus 1 squared minus 4. So thinking about the minimum point, so we want our minimum, it's going to be at 1 minus 4. I remember we take the opposite to this, the inverse of this minus 1, give 1 and minus 4 on the y-axis. Let's actually sketch these things in there at the moment then. This is our original curve that we've got. It looks quite steep. And this curve, if we just had this factorization as x plus 1, x minus 3, we would get our minimum point at 1 minus 4. So that's going to be right above this one, but 1 minus 4. The curve's going to give us a lot shallower than the one we've got. We're almost there then, because now we're at the same point where to go from this curve, the basic one, to our curve in red, we need to apply a stretch on the y-axis. And looking at those coordinates, put this in brackets, looking at those coordinates, to go from 1 minus 4 to 1 minus 20, we need to do a stretch factor on the y-axis of 5 times, don't we? Let's go from minus 4 to minus 20. So multiplied by 5. And that means we'd have to put a 5 in front of our double brackets. We've got these roots that everything needs to be stretched out by 5 times. So last of all for us then would be expanding that to actually check what we get. So we're going to have 5x squared minus 10x, because we've got minus 2 times 5. And minus 3 times 5 would give us minus 15. So again, our A would be 5, our B would be minus 10, our C would be minus 15 for this question.